In this video, we are going to be going over some data visualization skills by creating different types of plots and graphs that we'll be using throughout the semester. Using data visualization is useful. You'll often see graphs and different types of charts in various peer-reviewed articles, and it's helpful to see something other than just numbers in a spreadsheet. So it really helps to do exactly what it says, to visualize what the data looks like if you're comparing means to each other, if you're looking at frequencies, if you're looking at trends, and different types of graphs are going to help visualize your data in various different ways. We're going to start off making a bar graph for a simple frequency distribution in practice 3, and we want to see a bar graph or create a bar graph for the number of pull-ups performed by the swim team members. So let's go over to our data spreadsheet, and we can see the simple frequency distribution that we created for number of pull-ups. And the easiest way to create a bar graph based on a simple frequency distribution is to start by highlighting the frequencies, and then we can go to Insert, and then we can choose our column or bar graph option, and typically we'll just pick the first one. Now you will see that the bottom automatically numbers from 1 to 20. Okay. In some instances, and this is why I recommend only highlighting the frequencies, in some instances, maybe your numbers, and I'm going to switch this so that we have a good example, but let's say instead of 1 to 20, we started at the number 5 and went from 5 to 25. So this is just, bear with me for a second because the values are going to change in the frequency table since we made them based off of the pull-up or number of pull-up criteria. But let's say I had my frequency distribution starting at 5 going through 24. Okay. You will notice that the data changed in the chart. However, the values on the bottom still stayed 1 through 20. And if you try creating your bar graph by highlighting all of your data, it will think that you're putting in multiple series of data. So when you make a bar graph based on a simple frequency distribution, it's important that you only highlight the frequencies and insert those into your bar graph first, because then you can go in and, let's say we want our x-axis to match what this number of pull-ups column looks like, and say that doesn't start at 1, or maybe it's at certain intervals. So if you have it listed like by 2 or by 3 or whatever, we can right click on our graph and click Select Data. And the view of this will be slightly different between Mac and Windows, so if you have any trouble, just let me know. Typically what will happen is you have kind of like a box on the left for your y-axis, I believe, or maybe your x-axis. I can't remember in Windows which one it is because I don't use it that often, but you'll have a box on one side for one axis and a box on the other side for your other axis, and then you'll have options to edit or switch row or column that kind of goes above those. So if you're working with Windows and you're struggling, let me know. I'm happy to meet with you and help out. But for Mac, this is what will show up, and you can see that the horizontal axis labels is not filled in. So what we can do if we need to reformat based on the auto numbering that naturally occurs is we can click on this little icon, and that allows us to select data, in which case we want our x-axis to coincide with all of these values. right? So then we can press enter. We now have that cell range identified in the horizontal axis labels, and then we can click OK, and then you'll see that my axis labels have now changed. Okay, so that was for the sake of the example, if you needed to change information, but because we are not doing frequencies from 5 to 24, we're doing them from 1 to 20, I'm going to change this back to what we had it as before. Okay. Now what we need to do, and let me move this graph down here so we don't have busy stuff going on, is we can do a chart title. So honestly, as chart titles aren't super important to me for this class as long as they represent, for the most part, what's in your graph. That's what really matters to me. So a chart title like this, we're looking at frequency of pull-ups. So you could literally put frequency of pull-ups. You could put swim team pull-up outcomes, something that represents what is on the graph. As long as it makes sense, I'm okay with it. Okay. You'll also notice we kind of have some white space up at the top of here. And just to give you guys an idea of how you can change different chart elements, you can do it by, you can see like when I click on various chart elements, they have little blue dots that show up around them. And that tells you that you are editing that component of the graph. So earlier I double clicked on the x-axis and we could change different components about the x-axis if we wanted the labels in a different place, etc., etc. Right? So the same thing goes for the y-axis. We can double click on that. And this is where you can see bounds, right? So just make note you're in like the little bar chart formatting area. This is your axis options. We can change the bounds, so if we don't want so much white space on top, I can change my maximum to 2. And then you can also change the units by which that goes from 0 to 2, or how you are separating your minimum from your maximum pretty much. So if I do by 0.5, that's great. There are no 0.5s in this distribution, so really I could just do a major unit of 1. From where we have 0, 1, and 2. And that would represent my data just fine. Okay, so this is an area where you can change various graph components with relation to the y-axis. Same would go for the x-axis if we had kind of naturally occurring values that we inputted instead of specifying a particular range. So we've got graph content, we have the appropriate units in both the x and y directions, and then last but not least, we need to make sure that we have sufficient labels for those axes. So when we are editing a graph or a chart, so I'm going to just give you guys an example just so you can see. If I click outside of the graph, you'll see we are naturally redirected to the Home tab. If I click inside the graph, you will see that I have automatically been directed to a Chart Design tab that pops up only when you click on the graph. Okay, and from here, this is where you can add your chart elements if you're working on a Mac. Okay, if you're working on a Windows computer, you will see a little green plus sign in the top right-hand corner of your graph, and that is kind of a shortcut area where you can add chart elements. Not a function that's in Mac Excel, which I'm not 100% sure why, but there's a couple of options based on the type of computer you're working with. Either way, if you're working Windows or Mac, you should get this Chart Design tab, so the steps should still apply to everybody. In here, we can add axis titles, primary horizontal and primary vertical. And you'll see as I click on those elements, they pop up in my graph. Okay. I now can indicate what my axes represent. So this y-axis is representative of what we measured, which is the number of pull-ups. so I can label that accordingly. And then my y-axis is representing the frequency at which, or kind of like the number of people that were able to achieve each number of pull-up that we have listed from 1 to 20. So usually for frequency distributions, I just put frequency in the y-axis, and that is sufficient enough. Okay. If you click in your graph on different text elements, you can change the font size. I find that sometimes when we copy graphs into into your Word answer sheets, the text can be really small or it can also be really huge. And you can change font sizes in both Excel and Word. So if you copy a graph into Word and the text is way too large, if you click on the whole graph itself, you can just click on the up or down arrows. Right, so I'll show you an example of that really quick, and I'll just paste it at the very bottom of the answer sheet. So I want to copy, let's say, my graph and stick it in my answer sheet. Okay. This came out pretty nice. Usually when I try to format the spreadsheet so that the graphs look good. But just make sure that your elements are legible. That's the only thing that you really need to, check off your boxes here. However, if you wanted to change the size, all you have to do is click on the up or down arrows, right? And you will see that text elements now change size. Okay, so that's one way you could do it. You can also do the exact same thing in here, right? And they will all increase based on the starting size that they are at. So that's just an example on how to change text elements. And I realize we're kind of taking a lot of time on a very simple graph type, but all of these skills are going to apply to pretty much every graph that you make. So we'll take the time now, and then it's just practice in the other ones. So this is how we make a bar graph based on a simple frequency distribution. For our next example, we're going to be using the histogram chart option to create kind of a grouped frequency distribution. Okay, so histograms are characterized by bins, and the bins are separated by intervals. So there's a lower bound to the interval and an upper bound to the interval, which should kind of seem familiar based on how we built our group frequency distribution table. Now, this example was so that we could understand how to use a countifs function. And this table layout, I wanted to show you guys because we're going to use this layout in calculations in future activities. And so the more you practice stuff, the more you're exposed to stuff, the more you remember. So we created a group frequency distribution using a lower bound of, or basically using multiples of 5, with the lower bound starting at 35, upper bound moving at intervals of 5 but going up to 105. Okay, so we predefined these values, and then we calculated the frequencies that occurred in between each of these intervals. When we create a histogram, however, it will automatically choose the units that are displayed. So when we create our graph, our numbers are not going to match what's in this table. So don't freak out if you're like, wait, but this frequency is supposed to be 2 and it's 3. Okay, don't worry about it. This is just this was a different example in order to organize data in a group frequency distribution. When we actually graph it using a histogram, we want to use the raw data. So because this is for Planck time, we're going to highlight the raw data for Planck time. And then we're going to go to the Insert tab. And then we're going to choose the histogram chart type. If you're in online Excel, I don't believe this chart is available. So in order to make histograms for this class, which I believe we do in at least 2 more activities. You need to have a desktop version. Okay, unfortunately, there is no alternative. So you click the histogram chart, and you can see here, let me move this to a blank spot, that we have our x-axis values automatically starting at 38, and then they just fill up to a certain value, right? Which in this case is 116. So in order to change how our bins are organized, in Mac, you're going to double click on the bins. If you're in Windows, you will double click on the x-axis. So since I'm in a Mac system, I'll double click on the bins. That will bring up my formatting toolbar. And then we can change how our bins are organized in this area. Right now, it is auto-formatted. Okay. However, we can change how we organize our bins based on the width, right? Let's say we wanted to keep the intervals of 5, okay? And then now we can see that our bin widths are by 5, okay? We maybe wanted to set our intervals to 15, okay? In which we're grouping more people together, okay? So that's if we're doing bin width. We could also identify how many bins we want to have. So in this case, it set it to 5. Maybe we want 10. Okay, so the way that you organize your bins is going to drastically influence how you can visualize your data. And this will particularly be helpful in the future when we want to look at distribution shape. So you're not familiar with the terms yet, but if we're looking at skewness or kurtosis, looking at histograms and the shape of the histograms can greatly help us decide visually if we think a distribution is skewed or if it has kurtosis. But we're not going to worry about that just yet. For now, I just kind of wanted you to be familiar with how to change the bins based on different criteria. And then for our chart title, I'm just going to leave this as is for now because you don't have to submit this graph. But for chart title, we could say, swim team plank times. And then with our add chart elements, we can add our primary horizontal and vertical axes labels. So my x-axis would be representative of plank time in seconds, and my y-axis would be representative of the frequency, similar to my simple frequency distribution table. And then in your actual activity tasks that you do on your own, I would specify how I want you to organize the bins. And the same would be if you're doing any other types of assignments or assessments for histograms in this class. All right? For our next example, we're going to create a scatter plot, also in our practice 3 data. And I want to make a scatter plot that looks at a relationship between pull-ups, which I've indicated is the independent variable, and push-ups, which I've indicated as the dependent variable. Okay, so pull-ups independent, push-ups are dependent. When we look at our data in here, it is important that the way your data is organized matches your independent and dependent variable setup. So generally, you want your independent variable, which gets plotted on the x-axis. You want your independent variable listed first, and then next to that, you want your dependent variable. Okay. For the sake of this example, I am going to mess with the organization of this, so we're going to have data kind of in here twice. And the easiest way we can do this is by inserting a column. So if I want to insert, I just wait for that black down arrow to pop up in this column D. I can right click and click insert. This will automatically insert a column to the left. And then I'm just going to copy my push-up data and paste it so it's next to my pull-ups. And this organization is now set up for our scatter plot, right? Because we said pull-ups are the independent variable, push-ups are the dependent variable, and I want independent listed first, dependent listed second. Because Excel will automatically say pull-ups will go on the x-axis, push-ups will go on the y-axis. From here, we can just highlight these two columns of data, go to Insert, and then choose our scatter plot chart function. You can do different scatter plots, one with just dots, if you want to connect your dots with lines, if you want the lines with no markers, if you want jagged lines, right? So different options. We're just going to use the regular dot scatter plot, okay? And then you can see that it tried to create a chart title for us, which we don't really care about, okay? So we're going to change that on our own, and we can call this pull-ups versus push-ups. Sure, okay? Doesn't really matter how you label it, again, as long as it kind of just gets the basic idea across. We need our axes labels. Okay, so again, these are number of pull-ups and number of push-ups. And we can also notice the units, right? So the values are 0 to 25, and these match with the pull-up values, right? Nothing in this data set goes above 50 or 60, which we can't say for this side, right? So that's another way you can make sure that you've copied everything right, is if you have the appropriate unit values on the bottom. Okay, so our x-axis is representative of our pull-up, or let's say number of pull-ups, and our y-axis will be representative of the number of push-ups. Okay, and then that's, for the most part, pretty much it. Okay, sometimes if your data has like big white blank spots, so for this example we could say maybe we want to cut off our graph at 20. Remember that you can change your unit values by double clicking on the axis you want to modify. So if I want my maximum boundary to be 20 instead of 25, right, I can shift my data points around my graph area so that I kind of maximize or optimize how I'm viewing the data. White space on graphs usually isn't the best. So if we can minimize the white space, we have done a better job at looking closer at the relationships we are investigating. Okay. For scatter plots, we can also add some fancy trend lines, right? If we wanted to look at correlations, those are linear relationships, right? And so with a trend line, I'm just going to make this a different color so we can see it a little bit better, right? With trend lines, we can sometimes see or assess if a relationship exists between two variables or not. Okay. For this particular activity, when you make a scatter plot on your own, you don't have to include a trend line. However, if it helps you visualize the data better, feel free to add one. Okay. But the trend line kind of lets you know, like, this is the line of best fit that, for the most part, is smushed in the middle point of all of the data, such that the distance between each data point is relatively equal on both above and below the line. Okay, so the flatter or more horizontal this line is, the less of a relationship we would expect to see. So in this case, the number of pull-ups somebody can do doesn't necessarily dictate the number of push-ups they can do. If this line was steeper, going in a positive direction, usually we say that's a positive correlation, right? Which indicates that the more pull-ups a person can do, the more push-ups they would be expected to do. If the line had a more diagonal, sorry, my mouse is crapping out here. If we had a diagonal going downwards, which we would usually refer to as a negative correlation, that indicates that if you're able to perform more pull-ups, that dictates that you can perform less push-ups, right? So positive relationships, as one variable increases, the other one increases. Negative relationships would show as one variable increases, the other one decreases. Okay, but the flatter the line is, no relationship. Okay, so those are some components for scatter plots that could be useful for you in your tasks later. And then the last graph example that I wanted to show you guys is a multi-series bar graph. We will look at multi-series bar graphs when we have various means or group means that we are comparing. So for this example, we're going to go to practice number 2. And we're going to create a multi-series bar graph for the first 2 minutes of exercise for each pedal rate. Let's go back to practice 2. Okay, remember that we had our averages and our standard deviations calculated for various pedal rate groups during a graded exercise test. We're going to choose the first 2 minutes of exercise so we can highlight that range, right, going from our data labels to 2 minutes. And then we're going to insert. We're doing a bar graph, and we're just going to use the 2D clustered column. Okay, so when our chart inserts, and I'm going to pull this into the blank space so we can see this a little bit better. When our chart pulls in, you can see there is a blue series, an orange series, and a gray series. If you love colors like I do, you can format these series to different colors using the fill option in the format toolbar. So if you wanted it to be green, right? Oh, I changed the line. Whoops. We want fill, right? We can change it, and let's say we want it green. You can change it to green, okay? So you can get fancy with this if you feel like you need to. But in the legend area, right, when you have multiple series, you should have a legend that pops up. We can see green represents the low pedal rate, orange is the normal pedal rate, and gray is the high pedal rate. We then can see that our times have been listed down here. If you don't see times, it's probably because you didn't highlight this top row as your data labels. So the more you highlight, the more information goes into the graph. Okay? Just for an example, if you only highlighted the data here, you might get something that looks like this, in which case you don't have series labels and you don't have x-axis labels. So if you did this, okay, just for the sake of the example again, what you can do instead of, you could just delete the graph and then re-highlight everything, but it's important that you guys also know how to change different graphical elements. So if you ended up with something like this, you can always go to Select Data in the Chart Design tab, or you can right-click on your chart, which also has a Select Data option. Okay. From here, you can see Series 1, right? In our blue series, right, this was the low pedal rate. And we can assess that by looking at the average values in the first column, or 0 time point, right? 65 for the low pedal rate, that's the lowest value that we see in this first time point. So we can figure out, again, what our series would be based on the values that we see in the graph. And you can just rename this low pedal rate, right? And now you can see that as changed on the graph. And I didn't mean to press enter because that took me out of the select data, right? So then we can change the series names for each of these. And then we can also add horizontal axis labels right? So if we forgot to highlight, oh, whoops, I want to go up here. If we forgot to highlight those labels, we can always just identify what those labels are in the series, and then we have our time points added in. Okay, so if you messed up and you didn't highlight the data labels, both for the petal rates and the time points, that would be how you would change those graphical components. Okay. Similar to our other graphs, we're going to add a chart title. So for this example, we could say average percent heart rate max during a graded exercise test. Sure. Okay. You could say average percent heart rate max at various pedal rates, right? So doesn't matter what the chart title is, as long as it represents what's in the graph. We're going to add our axes labels. So this x-axis would just be time points, okay, and they are technically in a minute second format, okay, and then our y-axis would represent the percent heart rate max. Okay, and you can put percent sign, percent heart rate max. You can write out percent and then put a unit percent. Either one of those would be acceptable, as long as it's obvious what the units are. Okay. Another cool thing when you do multi-series bar charts is you can switch the row or column. Okay, so if I clicked this button here, what would happen is my time points would then be a certain series, and my pedal rates would become my x-axis, in which case I would need to change my x-axis label. So this switch row column function kind of comes in handy when you're organizing your data, right? And let's say you created a table and when you copied it into a graph or inserted it into a chart, it didn't come out the way that you wanted it to, and everything is backwards, right? That switch row column button is great if you misorganize your data. So that's just a cool function. Just make sure if you switch and you've already labeled stuff that everything, you go back and you check to make sure that everything is labeled as it should be. The other thing we often like to do with multi-series graphs when we're comparing group means to each other is to add error bars. If any of you have taken 312, which all of you should have made error bars before, because I used to teach the labs for that class. And the way we format error bars is we are going to go to Add Chart Element, we choose error bars, and we're going to go based off of a standard deviation. Okay, we're going to actually change that format, but just to get the error bars on, we're going to start there. Okay, so when we format error bars, they need to be according to the standard deviation that has been calculated for each group. And the auto format for error bars is going to actually show, I wanted to click on was those. You can see it shows a standard deviation of 1. And if I chose a different set of error bars, the standard deviation is still 1. Right? And we can see that the standard deviation that we calculated is definitely not 1 for any of these cases. So we need to reformat these. I'm going to start with my low pedal rate my low pedal rate error bars. So I just click on those and we can see the little blue bubbles highlight on all of my green error bars. I'm then going to go to Custom, and I'm going to choose Specify Value. From there, I can choose what my positive error is, as well as what my negative error is. Okay. When we're looking at standard deviation, and we'll go over what standard deviation actually represents in a later lecture, but standard deviation means that we have a mean, And then there is error above the mean as well as error below the mean. Right? So usually we say a mean plus or minus a standard deviation. So the positive would be the plus, the negative is the minus. And to format this to our data, we can choose our little chart selection tool over here. Whoops. And we can highlight the standard deviations for our low pedal rate from time point 0 to 2 minutes. Press enter. And then we're going to select the exact same range for the negative error. Right, so it's plus or minus technically the same sets of values for all of our low pedal rate bars in our chart. So we can then press OK, and you can see that our error bars have reformatted appropriately. We do this then for the other sets. So to go through the process again, you click on the error bars for the group that you want to edit. We go to our formatting toolbar, choose custom, specify value, and then we use our chart select tool to say I want my error or my standard deviation to represent my calculated standard deviations in the positive direction as well as the negative direction. And then you would do the exact same process for the last group, choosing the appropriate standard deviation range for both the positive and the negative. There we go. Okay, and now we have this cool graph with error bars. All right, so that's how you create a multi-series bar graph with error bars. The only thing I can think of that might be fun for you guys to mess with is the placement of the legend. So right now it's at the bottom, right, which is checked here. You could put it to the right. Okay, so that's one other element that we haven't covered yet, but this pretty much concludes our data visualization video. And take a peek at the next video to have a general overview of what your tasks are for this activity.